So we talked about the difference between rational and irrational numbers and what we can kind of do to identify whether or not a number is rational or irrational. Let's now kind of combine this with the context of what we've been talking about, where we've been adding radicals and where we've been multiplying radicals. So your goal here is you want to determine if a given sum or a product is rational or irrational. So let's look at an example. We have square root of 10 plus square root of 10. Remember, this is 1 square root of 10 plus 1 square root of 10. So in total, the answer is 2 square root of 10. And we want to know whether or not this is rational or irrational. So let's go ahead, take this idea, and put it into a calculator like Desmos. So I'm going to do 2 times the square root of 10. And that gives me this nonsense here. And in fact, because the square root of 10 doesn't follow a discernible pattern, and it will go on for forever, it's a square root. Whenever we see a square root that doesn't reduce into a nice, even whole number, we have to assume it's irrational. So this here is irrational. And it's irrational because of the square root of 10. Okay, but there are instances where we're going to have numbers that involve square roots but do show up as rational. So let me give you an example here. We have square root of 10 times the square root of 10. We actually talked a little bit about when we multiply the same root times itself, we do square root of 10 times square root of 10. In fact, let me show you this in Desmos. Square root of 10 times square root of 10, and it's just equal to 10. They undo each other in that regard. So square root of 10 times the square root of 10 is just 10. And this is rational. It's rational because it's just 10, right? It's just a regular whole number. It can be expressed as a ratio, 10 over 1 or 100 over 10. You know, any number that doesn't have a root in it is rational. So again, here we have root 5 plus root 5. So we get 1 root 5 plus 1 root 5. So this is equal to 2 times the square root of 5. Which, okay, I see the square root of 5 here. Let's see if that will reduce. Square root of 5. No, this isn't a nice clean number. So I'm going to go ahead and say that this is an irrational number. Because of the root 5. So again, if you remember from the multiplying radicals, right, we multiply what's inside. Here I get 81. So I could go ahead and do the square root of 81, and let's see if it gives us something nasty like these ones did, which is equal to 9. So 9 is rational. Good mental thing to do is that if you get these, numbers that you're really familiar with, numbers that you learned when you first started counting, it's a rational number. The second that you get these gross decimals, like these, probably start to think that it's irrational.